Hello everyone. Welcome to the fourth video for Intel Galileo Gen 1 development board. In the third video, we saw different ways in which we can connect Galileo via a Linux console. In this video, we will see how to burn a bootable image on SD card and boot up Galileo through SD card. Later in this video, we will also see how to blink an onboard LED via Linux console. We will also write a Python script to blink an onboard LED. We can download the bootable image provided by Intel from the given link. Let's go ahead and download this image. We will also need an application called Win32 Disk Imager. This application runs on Windows machine. It is used to write an image file onto an external device. We can download the application from the given link. Once the download is complete, we can install the application. We will follow the instructions given on the installation window. When the installation is successfully completed, we will extract image file from its zip format. We will now insert the SD card in the USB slot of our system using an SD card reader. Let us now open the Win32 Disk Imager application and select our removable device. Then we will select the image file that was downloaded earlier. We will then click on Write button on the window. Once the process is successfully completed, we will see a Write Successful pop-up on the screen. We will click OK and then exit. We will now safely eject the removable device and insert the SD card in the SD card slot of the Galileo. We will now power Galileo and view the boot up over serial terminal using PuTTY. Note that an LED will blink on the board stating that Galileo is booting up through the SD card. This LED is placed near the SD card slot. We will also see a blue screen. If you see a red screen instead, that means Galileo is not booting up through SD card. Sometimes the image is not successfully burnt on the SD card due to the absence of boot partition on the SD card, and it also doesn't give any error before. You will have to reinsert the SD card in the USB slot of the system and create a boot partition on the SD card. To create boot partition on the SD card, follow the instructions given on the screen. Once again, burn the image on the SD card and then eject and insert the SD card in the SD card slot of Galileo and then power up. A login prompt appears once Galileo is successfully booted up through SD card. Now we will try to blink an onboard LED via Linux console. We will use sysfs and its components. Sysfs is a virtual file system provided by the Linux kernel. By using virtual files, sysfs exports information about various kernel subsystems, hardware devices, and associated device drivers from the kernel's device model to user space. So let us start. /sys is an implementation of sysfs. We can see various devices under /sys/class. Here we will concentrate on the GPIO interface provided by sysfs. Onboard LED is connected to GPIO 3 on the Galileo Gen 1. In order to bring the control to this GPIO to the user space, we first need to write the GPIO number into the file called export under /sys/class/GPIO. Once we write number 3 to this file, we can see GPIO3 available under /sys/class/GPIO. Next, we will have to set the direction of this GPIO. In our case, we will set the direction of GPIO as out, and this can be done by writing out to the file named direction, which is available under /sys/class/GPIO/GPIO3. Once these configurations are successfully completed, we can program this GPIO by writing value 0 or 1 in the file name value available under /sys/class/GPIO/GPIO3. When we write a value 1, we can see the LED turned on. And when we write value 0 to this file, the LED is turned off. Next, we can also try to write a Python script to blink LED using this FS interface. Let us open a new file named blink_led.py. We will start with the hashbang. Next, we will import sys and time modules. Now we write a function called pins_export that will write GPIO3 to the export file and also set the direction of this GPIO as out. We will now write a function which will take the value as an argument and write this value in the file named value. Since this FS is a virtual file system, we will make sure that we handle the files properly using open and close APIs. Once this is done, we will initialize a variable count to 0 and we will write a while loop which increments the value of count till it reaches 9. We will turn on and off LED 9 times using this while loop. We will insert a sleep of 1 to insert a delay so that the LED on and off is clearly visible to us. We will now make this Python script executable by typing chmod plus blink_led.py and changing its mode. And now when we run the script, we can see LED on, LED off printing on the screen and the onboard LED turning on and turning off. Thank you for watching this video. I hope you enjoyed it.